So to kind of shift gears a little bit from our angles, but we're going to come back to them here in a minute, I want to look at this symbol. We've talked about it a little bit before. It's the square root symbol. And it's the inverse or the opposite of squaring something, a power of 2. If we say that 7 squared, which means 7 times 7, equals what? 49. Well, then the square root of 49 must be 7, because the square root is the reverse, or the opposite of a square, the power of 2. And everything in math, the operations are defined that way. I mean, the definition of addition, well, addition we defined on the number line, 3 plus 5 equals 8. The definition of subtraction is 8 minus 3 is the number such that when you add it to 3, it equals 8. So it's defined in terms of subtraction. Same with multiplication and division. 4 times 7 equals 28. Well, 28 divided by 4 is asking 4 times what number equals 28. So that's the 7. So division is defined in terms of that missing number, missing amount in our multiplication. The same with a root. The square root of x is defined to be what number squared equals x. So the square root of x equals y because y squared equals x. In other words, the square root of 9 equals what? 3, because 3 squared equals 9. Now I should be careful there. There's another answer that could go in there. Negative 3 can also be the square root of 9 because negative 3 squared would also be a positive 9. Remember, anything squared is positive. So the square root of 25, of course, would be 5 or negative 5. Good. How about the square root of negative 36? A lot of people would jump in and say negative 6. But what if you punch that in your calculator? What does it tell you? It tells you error. Why does it tell you there's an error? Because this is asking what number squared equals a negative 36. When I square a number, the result is always positive. There is no number that I can square that'll give me negative 36. Now, if we were to get into like a college algebra course, or even actually into an intermediate algebra course, they'll define something called imaginary numbers that allows you to take the square root of a negative. We're not getting into that in here. For our purposes, you cannot take the square root of a negative. So that means then, this symbol is called the third root, or cubed root. The cubed root of 8 equals 2 because 2 to the power of 3, which is 2 times 2 times 2, is 8. So that's just reversing a power of 3. Now, if I asked you to do negative 5 to the third power, what do you get? You get a negative 125. So if I asked you to do the third root of a negative 125, what should you get? Negative 5. That's exactly what you will get. So in a square root, I could not do the square root of a negative. But in a cubed root, in a third root, it is just fine. Because it is possible to cube a number and get a negative result. Now there are other roots, there's fourth roots, fifth roots, and so on. We're not going to get into those. Those aren't part of this course. But if you were to go on and take tech math, or like I said, college algebra or quantitative reasoning, you would get into those other higher powered roots. We want to focus on that square root. And look at something like this, the square root of 0.4. Now, a lot of people want to say, well, isn't that 0.2? But you got to be careful. 0.2 squared is 0.2 times 0.2. 2 times 2 is 4, but how many decimal places have to be in that answer? There's 1, 2, there has to be 2 decimal places in the answer. That has to be 0.04. The square root of 0.4 is going to be some very long decimal, 0.6324, or 25 we'll call it. It's called, we call an irrational number. It'll go on forever without ending. So if I look at this, let's say the square root of 0.09. Now 9 is a perfect square just like 4 was. But this one will work out to be 0.3. Why will it work out? Well, how many decimal places does this have? 2. When we square a number, if we have a 0.2, if it has 1 decimal place, if we square it, how many decimal places will the answer have? 2, right? Well, since square rooting is reversing that, if we start out with 2 decimal places, our answer will have 1. So when you square root a number, a decimal, not only does the number numerically have to be a perfect square, but it has to have an even number of decimal places. For example, 144 is a perfect square, correct? It's 12 times 12. Will that give me a nice perfect decimal square root? Well, 144 is a perfect square. How many decimal places does that have? 4, right? So how many decimal places do you think I'm going to have in my square root? 2, half of that, 0.12. If you try that, do you guys know how to do square roots on your calculator? Most of you have an x squared key that looks like that somewhere on your calculator. Might be in a different location, but it'll be there. You usually have to hit shift or second and then that x squared key because the square root's up above it. Then type in the 0.0144 and you'll spit out 0.12. One thing you'll notice, by the way, on all the ones I just did here, on these decimals, the answer is bigger than what I started with. 0.6325 is definitely bigger than 0.4. 0.3 is definitely bigger than 0.09. And 0.12 is a lot bigger than 0.0144. We're so used to when we take a square root getting a result that is smaller. But remember, if I am squaring a number, if I'm squaring the number 2, 2 times 2 is 4. That gets larger because I'm multiplying it by something bigger than 1. 1 squared is 1. Because 1 squared and 1 times 1, when I multiply anything by 1, its value stays the same. If I have 0.5 squared, that's going to give me 0.25. It got smaller because I'm multiplying 0.5 by another 0.5. I'm multiplying it by something smaller than 1. And when I multiply by something smaller than 1, the number gets smaller. So when I'm doing squares, or any power for that matter, if I'm starting with something larger than 1, the result will get larger. If I'm starting with something smaller than 1, the result's going to get smaller. For example, if I have 0.12 to the third power, that's smaller than 1, so my result is going to get smaller. I get 0.001728. When we had something like 2/5 squared, recall we said that was 2/5 times 2/5. 2 times 2 is 4, 5 times 5 is 25. But because of the way the fractions were multiplied out, we said this could have been thought of as just taking the numerator squared over the denominator squared. 2 squared gives us 4. 5 squared is 25. So when we go to take a square root, the same thing applies. We can split up the power to do just the numerator and then just the denominator. Same here. We can square root the numerator and then square root the denominator. What's the square root of 4? 2, and the square root of 25 is 5. So if I ask for the square root of 9 over 100, I can do the square root of 9 over the square root of 100. What's the square root of 9? 3. Square root of 100? 10. So how does these square roots fit in with our angles? Well, if we have a triangle, and if it is a right triangle, the two sides that form the right angle are called legs. The other side that is across from the right angle is called the hypotenuse. It does not form the right angle. It's also going to be the longest side of the triangle. So the legs form the L. That's one way to remember them. When we label a right triangle, we typically label the legs sides A and B. It doesn't matter which one's which. The hypotenuse is always labeled as side C. And there's a relationship that was developed by a Greek mathematician named Pythagoras, which is called the Pythagorean rule or Pythagorean theorem. And the Pythagorean theorem states that in a right triangle, the length of side A squared plus the length of side B squared is going to equal the length of that hypotenuse squared. Most of you, I'm sure, have either seen or heard of that one before, right? A squared plus B squared equals C squared. So in a right triangle, if this is 6 inches, 8 inches, and 10 inches, which side is going to be side C? The 10 inches. The hypotenuse is always the one that doesn't touch the right angle, and it's always the longest side. So it doesn't matter which one for the 6 and 8 is A and B, so I'm just going to label them. So 6 would be A, so that's 6 squared, plus 8 would be B, so 8 squared equals 10 is C, so that's 10 squared. 6 squared is 36. 8 squared is 64. 10 squared is 100. 36 plus 64 is 100. So that holds true. So we can use this to test if a triangle is a right triangle. So this is 9. This is 40. And 41. Which two sides would have to be the legs? 9 and 40 or 40 and 9, yes. So that makes 41 the hypotenuse. That would be C. So A squared will be 9 squared plus B squared will be 40 squared plus, equals C squared would be 41 squared. 9, and I shouldn't put an equals there. I should put a question mark or leave a blank there, but because we don't know if they're equal yet. 9 squared is 81. 40 squared is 1600. 41 squared is 1681. I add these together, I get 1681. Yes, they do equal, so I can put an equal sign in there. So this is a right triangle, and that is a right angle. So for this one, if I have 12, 35, and 37, which two sides would be A and B? 12 and 35. And so 37 would be C. Again, I don't know if this is a right triangle, but I know that the hypotenuse, if it is a right triangle, the longest side must be the hypotenuse. The two shorter sides must be the legs. So 12 squared plus 35 squared, and we're checking to see if that equals 37 squared. So what is 12 squared? 144. 35 squared is 1,225. 37 squared, 1,369. If I add those, I get 1,369. They're equal. So yes, there's a right angle. Where's the right angle at?
It's supposed to be between 12 and 35, but we all know it's between 12 and 37 on that.
Has to be between the 12 and 35. Yeah, I purposely drew that not to scale. Another application of that is if I don't know one of the sides. So if I tell you that that's a right angle, and that this is 5 feet and this is 12 feet, we can use it to find the missing side. The 5 and the 12 are the legs because they make the right angle, so those are A and B. And the hypotenuse, side C, is where X is. So A squared plus B squared equals C squared. We'll just fill in. A is 5, so that's 5 squared, plus B is 12, so that's 12 squared, equals C is X, so that'll be X squared. 5 squared is 25. 12 squared is 144, equals X squared. 25 and 144 is 169, equals X squared. What do we have to do to that? X has been squared. To solve that, we have to do the opposite, which would be square root. Square root of 169 is 13. The square root and the X squared cancel out and give us X. X is 13. The other ones were in feet, so that'll be in feet. Does that make sense? Or we might have something like this, where I tell you that that is a right angle, and I might tell you that this is 11 inches. This is 61 inches, and I want to find X. What two sides need to be A and B? X and 11. So A and B, 61 then is side C. So A squared plus B squared equals C squared is going to become, A is X, so that's X squared, plus B is 11, so that's 11 squared. C is 61, so that is 61 squared. X squared doesn't change. 11 squared is 121. 61 squared is 3,721. Now what do we have to do? Subtract 121. We're going to solve for X. So X squared equals 3,600. And then square root. So the square root and the X squared just cancel, give us X. Square root of 3,600 is 60. So that is 60. Any questions? So let's do an example here. Let's say you're younger and you want to sneak out of the house. So you put a ladder up to your window. But your house has a fence not far away from the side of the house. The bottom of your window is 12 feet off the ground. The fence out here, I should draw that a little better maybe. The fence is only 8 feet away from the base of the house. Your ladder is 15 feet long. So here's the question. You want to set up this ladder before you go to bed. It can't go out past the base of the wall. But if you set it up here, if it's too tall, it is going to break your window. Does that 15-foot ladder fit in there? Now we can approach this a couple of different ways. One, I could look at it as the triangle of what's actually there with the wall and the ground, and I could draw that triangle. The wall and the ground better be at a right angle to each other, right? That would be the right angle for that wall to be at. So that's 8 feet and 12 feet. Figure out what that distance would be. So 8 squared plus 12 squared would give us x squared. 8 squared is 64. 12 squared is 144. Still equals x squared. Adding those is 208 equals x squared. And we have to square root that. So the square root of 208 is going to give us 14.42. Will that 15-foot ladder fit in there? No, 14.42 is all we have there. 15 foot's going to get up and break the window. The other way we could have done it is we could have done, here's a 15-foot ladder. We've got 8 feet here. How high up do we have to go to get that ladder in there? We would have ended up with something a little bit larger than 12 feet. So it's going up the wall further than 12 feet. So a lot of these, there's multiple ways you can set them up. That is the end of our new material. There will be a new quiz due tomorrow. That's Wednesday at 11:59 p.m. There's new homework that is due for next Tuesday in class. Okay, so I promised you an extra credit question. This is a fun little question. Since it's hunting season, it fits in. So you're at hunting camp. I know that looks like a teepee, but pretend it's a tent. My artwork, we've already established the extent of my artwork. So you're at a hunting camp. You set out walking from camp. From camp, you walk 6 miles due south. At that point, you sit for a while, and you see a bunch of flock of birds fly over, and decide that, you're not going to see anything there. So you turn, and you walk 9 miles due west. At which point pretend that looks like a bear. You see a bear. And you shoot him. I know, it's a little morbid. So you shoot a bear. You realize you have to drag this bear now back to camp. You drag the bear from exactly where you shot him back to camp, and it is exactly 6 miles. So the question is, what color is the bear? And you must be able to explain why.
Black bear because we are in Wisconsin.
I'll let you guys think about that one and email it to me if you want to. Otherwise, you can tell me next class on Tuesday. For those of you that were paying attention, yes, the lengths do not match up. They don't add up, do they? So that's a clue. The reason why they don't add up is what tells you what color the bear is. I'll leave it at that.